Hello and welcome once again to another interesting video. This is Paragon Pathfinders, and on this platform we take stress out of learning science. I promise to make it less complicated and easier for you to understand. Without further ado, let's get down to business. In today's video, I'll be teaching you how to find the inverse of a 3 by 3 matrix. This looks quite complicated, but trust me, it's very simple and straightforward. In order to find the inverse of a matrix, there are 4 steps you must know and follow every time. The first step is you must find the determinant first. Yes, this is a 3 by 3 matrix, and what makes it a 3 by 3 matrix is this is our first row, our second row, and our third row. Here we have our first column, second and third column. So you have to first of all find the determinant of this matrix first. After finding the determinant, the next thing you're going to do is to find what we call the cofactors. I'm going to show you how to do that once I start solving this very problem. After finding the cofactors, you need to transpose the cofactors that you've gotten. That's the third step. Transpose the cofactors. And finally, you're going to divide the adjoint, which is a transpose of the cofactors, by the determinant. You will divide the adjoint, which is also called the transpose matrix, by the determinant. And having followed these 4 steps, you will arrive at the inverse of whatever matrix you're given or this matrix. All right, let me show you how to do it. So the first thing that we're going to do is to find the determinant. In finding the determinant, since this is a 3 by 3 matrix, I am going to break it down from 3 by 3 to 2 by 2. And how do we do that? We're only going to work with the first row. We'll use the first row to break it down into simpler matrices. And that's going to be, this is equal to, so for the first one, I'm going to bring out a 1 here. Then you hide the row and the column where 1 is found. If you hide the row and the column where 1 is found, whatever remains now belongs to 1. We have negative 1, 7, 5, 2. We put it down here. Negative 1, 7, 5, negative 2. Do not forget to apply your sign constant, which is plus minus plus. And that's what we're going to use to find the determinant of this matrix. If the first one is a plus, because this is a positive 1, the second number is going to be a negative. Therefore, we'll have a negative 0, right? And to find the matrices for this second number here, we're going to hide the row and the column. If we do that, we'll have 3, 4, 7, negative 2. This is for the second one. And lastly, we have a 2 here, right? So this is going to be a plus 2. Hiding the row and the column for 2, this is the row, and here we have the column. We shall obtain 3, negative 1, 4, 5. Now let's go ahead and simplify this expression. We're going to simply multiply across. This is the major diagonal, and here we have the minor. We are going to subtract the minor from the major, and doing that, we're going to have 1. Negative 1 multiplied by negative 2 gives us a 2, minus 5 multiplied by 7 gives us a 35. This part goes away because this 0 is going to multiply everything inside here. Therefore, this goes away. It's going to go away because 0 is going to multiply everything. This one is not needed anymore. So let's work on this. We have a plus 2 here. 5 multiplied by 3, this is the major diagonal. 5 multiplied by 3 gives us a 15. Therefore, 4 multiplied by negative 1 is a negative 4. We have 15 minus a negative 4. Let's simplify to check what we're going to obtain. 2 minus 35 gives us a negative 33. 15 plus 4, because negative multiplied by negative gives us a positive. Therefore, 15 plus 4 gives us a 19. 1 multiplied by negative 33 gives us a negative 33. 2 multiplied by 19 gives us a 38 plus 38. This is equal to negative 33 plus 38 gives us a 5. Therefore, the determinant of matrix P is equal to 5. It can be written this way, or determinant of P. This is equal to 5. We have just concluded the first step where we found the determinant. The next thing that we're going to do is to get the cofactors of this matrix. I'm going to show you how to do that. It takes a little bit of time, but definitely we'll surely get there. Let's go ahead and find the cofactors. I'm going to write my determinants up here so that we do not forget. Okay, to find the cofactors of this matrix, I'm going to form a very big matrix. Let me do it up here. Okay, to find the cofactors, we're going to take note of this. This is a sign constant that applies: plus, minus, plus, minus, plus, minus, plus, minus, plus. This plus, minus, plus applies to the first row. The negative, plus, negative applies to the second row, while the plus, negative, plus applies to the third. So these signs are going to multiply whatever cofactors we're going to obtain afterwards. Using the same system we used to find or to break it down into simpler matrices, we're also going to employ the same method to obtain the cofactors. For the first row, we're going to hide the first row where 1 is found and the column where 1 is found. Therefore, we're going to have negative 1, 7, 5, negative 2. So we're going to do this for every number inside this box. I'm going to call it a box for easier understanding. But do not pick or rewrite the numbers. Leave it as it is. Like whenever you find the matrices that belongs to any of these numbers, just copy it down, but do not include the parent. I would say the parent so that you understand. So let's assume this is the parent, and here are the kids for this number. So you simply write down the kids and leave the parent. When we're done for this, we'll go to the next one, right? So for this second number here, this is where it is found. This is column 2, and this is row 1. So the kids for 0 are simply 3, 4, 7, negative 2. So I'm using these terminologies for easier understanding or comprehension. So for 0, the kids are 3, 4, 7, negative 2. We leave 0, right, and copy down the kids. And for the last one, we simply hide the column and the row. Then the kids are going to be 3, negative 1, 4, 5. That's how to get the cofactors of a matrix. I believe you've understood my explanation. Now we're done for the first one. Let's go over to the second one. So for this one, we're going to have, remember that this is a plus, This is now going to be a minus. So for 0, we hide the row where 0 is found. And the column, we're now going to have 3, 4. We have 3, 4, 7, negative 2, 7, negative 2. And for the last one, it's a plus. That's for 2. We hide the row, or the row where 2 is found. And the column, we have 3, negative 1, 4, 5. 3, negative 1, 4, 5. Okay. And for the next one, we are going to also apply this sign constant here. So now we're going to go to the second row, which is our 3. This is a 3. So to get the children, I will say children for a better understanding or comprehension. So for 3, we simply hide the row where 3 is found and the column. So if we hide the row and the column, we're going to be left with 0, 2, 5, negative 2. 0, 2, 5, negative 2. So this one right now is going to be a negative, and the next one is going to be a plus. Now let's go over to the next number after 3. We're trying to find the cofactors here. The next number is a negative 1. We hide the column where negative 1 is found and hide the row. What do we get? We have 1, 2, 4, right? Negative 2. 1, 2, 4, negative 2. 1, 2, 4, negative 2. And the next one is a negative. That's for 7. If we hide the column where 7 is found and the row, what do we have left? This is the column. And here we have the row. We have 1, 0, 4, 5. 1, 0, 4, 5. Now let's do for the last set of numbers, which is the last row. Remember to apply the sign constant. Now it's going to be a plus. For this one here, if we hide the column and the row, what do we get? 0, 2, negative 1, 7. 0, 2, negative 1, 7. This is a minus this time around. And for 5, which is the next number, if we hide the column and the row, right, what do we get? We have 1, 3, 2, 7. Hiding the column and the row gives us 1, 3, 2, 7. 1, 3, 2, 7. And lastly, we have a negative 2 here. So if we hide the row and the column, what do we get? 1, 0, 3, negative 1. 1, 0, 3, negative 1. So I want you to see these cofactors as children to these numbers. They're like kids, while these numbers are their parents, right? So that's how I want you to see it. It's a very simple analogy to help you comprehend better what we're doing right here. Now, the next thing that we're going to do is to find the determinant of all these matrices that we have formed here. So let's go ahead and do that. These are 2 by 2 matrices, and they're going to be quite simple to find their determinants. I'm going to put them here. Remember, I told us that we are going to find the transpose from the cofactors. So if we break this down and get their determinants, those determinants will be their cofactors. Okay, so let's quickly do this. Remember to subtract the minor diagonal from the major. Negative 2 multiplied by negative 1 gives us a 2. So hence we're going to have 2 minus 5 times 7 is a 35. For the next one, we have a negative value. Negative 2 multiplied by 3 will give us a negative 6. This is a negative 6 minus 4 times 7 gives us a 28. 28. And for the last one, we have 5 times 3. 5 times 3, I'm going to put the plus here. 5 times 3 gives us a 15 minus 4 multiplied by 1 gives us a negative 4. Therefore, we have negative 4. Okay, now let's go over to the second row. Negative 2 multiplied by 0 gives us a 0. Remember, this has a negative value here, a negative sign rather. Negative 2 multiplied by 0 gives us a 0, minus 5 multiplied by 2 gives us a 10. And for the next one, we have a plus. Negative 2 multiplied by 1 gives us a negative 2, minus 4 multiplied by 2 gives us an 8. And lastly, we have 5 multiplied by 1. This gives us a 5. There's a negative value here, negative sign rather. 5 multiplied by 1 gives us a 5, minus 4 multiplied by 0 gives us a 0. And lastly, 7 multiplied by 0 gives us a 0, minus negative 1 multiplied by 2 gives us a negative 2, minus 7 multiplied by 1 gives us a 7. 3 multiplied by 2 gives us a 6. And lastly, negative 1 multiplied by 1 gives us a negative 1. 3 multiplied by 0 gives us a 0, minus 0. All right. Now we're going to simplify this expression inside this, would I call it a bracket or a box? Now, whatever we get becomes the cofactors, right? So let's go ahead and simplify all this inside. Okay, 2 minus 35 gives us a negative 33. Negative 6 minus 28 gives us a negative 34. Negative 34 multiplied by a negative number gives us a positive 34. And lastly, negative times negative here gives us a positive. 15 plus 4 gives us a 19. For the next row, 0 minus 10 gives us a negative 10. Negative 10 multiplied by 10, or a negative number multiplied by this negative sign here gives us a positive 10. We have a positive 10. Next up, we have negative 2, negative 8 gives us a negative 10. For the other one, 5 minus 0, or 5 minus 0 gives us a 5. Negative multiplied by 5 gives us a negative 5. For the last row, we have negative multiplied by negative gives us a positive. Therefore, 0 plus 2 gives us a 2. 7 minus 6 is a 1. 1 multiplied by this negative sign outside of the bracket gives us a negative 1. And lastly, -1, -0 gives us a -1. These are the cofactors of our original matrix. Okay, now what's the next step? Remember I told you that when you get to this point, or once you've gotten your cofactors, the next step is to transpose these cofactors. After transposing these cofactors, you're going to divide them by the determinant of the original matrix, and that will give you the inverse, which we're looking for. Now, what else do we do at this point? How do we transpose this matrix? If we transpose this matrix, we're going to get the adjoint. The adjoint, the adjoint of P is equal to P transpose. So if we transpose this matrix, we're going to get the adjoint, right? So this is the transpose. If we transpose it, we're going to get the adjoint. So the adjoint is equal to the transpose, and the transpose matrix is also equal to the adjoint. How do we do this? To transpose the matrix, I'm going to write it right here. Adjoint of P, this is equal to the row becomes the column. That is what we mean by transposing. So when you transpose a 3 by 3 matrix, the row becomes the column. This is the first row. Here we have the second, and this is the third. Whenever you're transposing a 3 by 3 matrix, the row becomes the column, and the column becomes the row. If this is the first row, transposing it will give us a -33, right? So this row now becomes the column. Next, we're going to have 34. And lastly, we have a 19. This is for the first row. Let's transpose the second row. The second row, we have a 10. The next number is a -10. The last one is a -5. And lastly, we have the third row. We have a 2 here. The next number is a -1. This is a -1. And lastly, we have a -1. So this now becomes the adjoint. This is the adjoint of this matrix. And finally, to find the inverse, we're going to divide this adjoint by the determinant of this matrix. And boom, we have our inverse. It's as simple as that. It only takes time, but trust me, you will definitely get there. To obtain the inverse of this matrix, we are going to use this formula. P inverse is equal to, because this is our matrix P, therefore the inverse of P is equal to the adjoint of P all over the determinant of P. This will give us our inverse. Since we have the adjoint already, which is this, and we have the determinant, which is that, we can go ahead and find the values that we're looking for. So our P inverse is equal to, so I'm going to copy this down because this is our adjoint. We have a -33, we have a 10, and we have a 2. For the second row, we have 3, -10, -1, 34, rather, not a 3, this is a 34, -10, -10, and -1. And lastly, we have 19, -5, -1. 19, -5, -1. All this over 5. So this 5 divides everything inside. And I'm going to copy it up here. is our P inverse. All right, let's continue with it. We're going to have negative 33 over 5, 10 over 5, 2 over 5, 34 over 5. Remember that this 5 divides everything inside this box. So 34 over 5, negative 10 over 5, negative 1 over 5. And lastly, we have 19 over 5, negative 5 over 5, negative 1 over 5. I'm going to simplify this to get our answer. Let me clean what we have in here. Okay, negative 33 over 5 is indivisible, so we're going to leave it as it is, negative 33 over 5. 10 divided by 5 gives us a 2. We have a 2 here. 2 and 5 are indivisible, so we're going to write it 2 over 5. We leave it as it is. Next up, 34 over 5, they cannot go. We leave them as they are. The next one is negative 10 over 5. That gives us a negative 2. Negative 10 divided by 5 gives us a negative 2. This one remains as it is because they cannot divide themselves. Negative 1 over 5. And the last row, we have 19 over 5. They cannot divide themselves. We have 19 over 5. Negative 5 divided by 5 gives us a negative 1. And lastly, these two cannot divide themselves. Therefore, we leave them as they are. We have negative 1 over 5. This now becomes the inverse of the matrix P. This is how to find it. It's not really difficult. It's a straightforward process that you can easily do. Remember what I told you in the first place. If you want to find the inverse of the matrix, the first thing you're going to do is to find the determinant. After finding the determinant, you find the cofactors. After finding the cofactors, you transpose the matrix, and that will give you the adjoint. When you get the adjoint, simply divide it by the determinant, and you have your inverse. Thank you for watching this video, and I hope to see you in the next video.